The University of Wyoming School of Energy Resources is trying something new in Northeast Wyoming. The Carbon Storage Assurance Facility Enterprise, or Carbonsafe Initiative. The goal of the Carbonsafe Initiative is to determine if carbon dioxide can be safely and permanently sequestered underground. Scott Quillinan, Research Director, talked about the feasibility study they are conducting at Gillette's Dry Fork Station.
Wyoming Carbonsafe is focused on investigating the feasibility and practical, secure, permanent geologic storage of carbon dioxide emissions at a coal-fired facility near Gillette, Wyoming. So what is a feasibility study? If you take a 30,000 level, what we're really doing is we're trying to find a storage tank that's large enough. We want to make sure if we put it in that storage tank in the subsurface, it'll stay there permanently, securely, and safely. And we want to know how much it costs, what the legalities of it, and what the risks are of putting CO2 down there. So those three questions, this is kind of our project map. So it's really in three components. Right now we're working on field operations. So we've been doing public outreach, drilling a test well. The test well will be coring, sampling fluid, logging. Later this year we'll be coming back and collecting some seismic data. And Fred, I can't wait until we get back out and do some field work. We'll take all those rocks, fluids, everything back, bring it to the lab, and that's where we can start to do the reservoir characterization. We can put all those pieces together, put them into models, look at the economics, and we can really start to get a feel for what a commercial project might look like here in Gillette, Wyoming. And then the most important part is to package that up and then communicate it back to the stakeholders, Basin Electric, the community, and just let them know what a commercial project might look like, might feel like, and ask the question if we want to go to the next step. So our field operations did start earlier this spring. We were at Gillette, the Campbell County Library on February 21st. 2 days later, we stopped at Sheridan College. There was 135 people that came out from Gillette to listen to this project and learn a little bit more about it. We used the Saturday U program as a vehicle to get it out to the public, and it was pretty successful. So we had Kip give a regulatory and legal update on carbon capture and storage. Fred and I talked a little bit about the science and what happens. And then we had Jessica Western from the Hobbs School of Natural Resources, and she just had a conversation with the audience and kind of asked the questions of, what would you like to see if you were going to permit a project like this in this area? And so we had an opportunity to just kind of take down those ideas on the whiteboard. And the great thing about a research project is now we can take everything we heard from the community and kind of fold it into questions and start answering those as we go through this project. So what was the community wanting to know about? They want to know if there's any risk to drinking water. They want to know about jobs. They want to know about who owns it and who's liable if you inject it. They want to know about the overall benefit to Wyoming. So these are the things that as we go through our feasibility study, we'll fold those in and we can come back and communicate it back. So thanks to the folks here at Basin Electric and Dry Fork Station, the dirt work began March 31st. Western Fuels handled all of the dirt work for us. And I might be biased, but when I went out and looked at the well site, it was the best one I've ever seen. I don't know about you, Fred. So drilling began at April 13th. Here's Brett, our trusty driller, blessing the bit before it goes down into the hole. We were 2 days ahead of schedule. Everything was ready to go. Thanks again to everybody here on the ground. So we started this project ahead of schedule and stayed ahead of schedule. And like we already mentioned, there's a lot of local contractors that we're using. If and when we can, you take those research dollars and you just kind of funnel them out into the community, and it's a great economic benefit for everybody involved. So one of the major goals is getting rock out of the hole. We're going to take a lot of core from this well. We're going to take core from 4 different intervals. We've already collected 30 feet of core from the Mowry and 70 feet of core from the Muddy. We've got the Dakota and Lakota. We got 150 feet there, 130 feet. Yeah. And this morning just came out of the hole. We took these lower Jurassic sands. We've got a full core hole of 180 feet. So the next step is to go back and drill down to this Minnelusa, and we're going to take another 180 feet there. So everything so far has gone fantastic. So what do we do with the core? So on the left there, what you're seeing is a 4-inch core. If you zoom in to about a 200 nanometer scale, you see it there. If we zoom in a little bit further, these little blue spots, that's the dyke pore space in the rock. That's what we're exploring for. We want to find places in this rock that we can put CO2, and that'll tell us how much CO2 we can put in there, how much our plume footprint might be. It'll tell us a lot about the risk of putting CO2 into that rock. And it gets pretty complicated pretty quick. But that's essentially what we're looking for in order to figure out how much CO2 we can put down there. The next step, after we get the core out of the hole, is to go back in and log it. And we'll take geophysical measurements all the way up and down the wellbore. And that'll give us an opportunity to scale up from this 4-inch core over this 180 feet to look at the whole strata vertically all the way up and down the hole. And this will tell us a lot about the different lithologies. It'll tell us about how thick our seals are. It'll tell us about compositions of the fluids, and so on and so on. So the next step is we have a core. We know a lot about the vertical from the log. We need to be able to take that and extend it laterally over the whole site. So on the left there, what you see is, okay, so we have our reservoir rock there. Right above it at the same scale is one of our seals. So we're also collecting core from the seals on top of these reservoirs. And you can just see the difference in the pore space and the porosity between what a reservoir looks like and a seal. So it's a lot like a ceramic cup that would hold your coffee. Even though the ceramic has a porosity and permeability, it's as such that it can hold the coffee within the cup. So what we're looking for are these reservoir and seal pairs. But then we need to be able to extend those reservoir and seal pairs out over the study area to make sure that we don't have any faults that may be a source of leakage. We'll also be looking for structural traps, or we're looking for stratigraphic traps, and that'll give us a degree of confidence of how well we can hold a CO2 column in any of those reservoirs. So at the end of the day, this is what it looks like. You take all your geophysical data, you take all your well measurements, everything you got from the logs, the core. We haven't talked much about the fluids, but they also go into it. They play a major role here. And then we can start to simulate, build these high-resolution geologic models. We can start to run numeric simulations. We can start to dynamically inject CO2 to see how these rocks behave, how they react geochemically, how they move in the subsurface. This will tell us a lot about the feasibility of injecting CO2 at this site. And then we can start to talk about how many wells you would need to inject CO2 in this site, if you would need water production wells. So then we can use that to inform the economics and tell us practicality of CO2 injection here. So again, at the end of the day, it's about folding all this up so we can make informed decisions about a commercial scale project here just north of Gillette, Wyoming.